My name is Cindy and we will be talking about the blood and tissue nematode. For our learning objectives, at the end of this lesson, the student must be able to explain the different characteristics of the blood and tissue nematodes, identify the vectors that transmits the parasites, describe their respective life cycles, and to properly identify the different diseases or infections that they cause. For our introduction, the word nematodes came from the Greek word nema, which means thread, and eidos, or form. The characteristics of the nematodes is that 1. They are bilaterally symmetrical and vermiform. Second, the body has more than 2 cell layers, the tissues and the organs. Third, a primitive body cavity. And fourth, a simple digestive system. Number 5, their body is covered in a complex cuticle. 6, they have no circulatory system, which means they have no blood system. And 10, they live just about everywhere, as many species are endoparasites. They are transmitted through arthropods.
Today, we are going to discuss about the physical appearance and the unique characteristics of our blood and tissue nematodes. To start off, we are going to discuss about the size. One of the very unique characteristics of our blood and tissue nematodes when it comes to size is that the female worms are 2 times larger than the male worms. We have Bacteria bancrofti, which is 10 cm for female while 4 cm for male. Brugia malai, we have 43 to 55 mm for female, while for male, we have 13 to 23 mm. For loa loa, we have 25 to 40 cm for female, while for male, we have 20 cm. Manzonella prestans, we have 70 to 80 mm for female, while for male, we have 45 mm. Manzonella ozardi, we have 65 to 81 mm for female, while for male, it is unknown, but I'm sure that it's just the half of the size of the female. Drawn to differentiate a parasite which has a sheath on it while one without. So the upper part of the picture, this is a nematode that doesn't have a sheath, while for the lower one, this another lining, this is what we call a sheath. This is what we call a bag-like structure that covers our worm. So let us differentiate the different nematodes that falls on the sheathed and the unsheathed part. So for worms that doesn't contain a sheath, these are Manzonella perstans, Manzonella ozardi, and Onchocerca volvulus. While for the worms that contains a sheath, we have Brugia malai, Wuchereria bancrofti, and loa loa. Let us now proceed to the nuclei and the tail of our worms. We can also differentiate it by these characteristics. So first, we have Wuchereria bancrofti. Wuchereria bancrofti has a coarse but well-separated nuclei. As you can see here, the nuclei are well separated and it's very coarse. While for the tail, we have no nuclei. So at the end of the tail, there are no nuclei present, and it tapers at a very delicate point. Next is we have another drawing, which is the Brugia malai. So Brugia malai, a very distinct characteristic which I have said earlier is that it has 2 nuclei at its end, the end of its tail, and it is connected by a very fine thread. This tail is tapering very irregular, and the nuclei is very crowded, and it is closely folded angular. Next, we have loa loa. The nuclei of loa loa is coarse and crowded. This is the coarseness. We can see the coarseness. And the nuclei are very close to each other. We can see the nuclei up to its tip. And the tip is rounded and curved, and the curveness is extended to its tip. Next thing that we are going to discuss today is the movement of our different blood and tissue nematodes. I am sorry because I wasn't able to show you guys what is the movement of these nematodes. So I'm just going to describe it to you. So first we have Wuchereria bancrofti. We have a graceful curves in a movement of spiral. Next for Brugia malai, we have closely folded and angular. It's like a zigzag motion. Next is for Loa Loa, we have irregular angular curves. And for Manzanella perstans, we have regular curves and loops. So, you know the um, alpha? Yeah, the alpha sign. Yeah, something like that. It has a curvish movement. Next is for Manzanella ozardi, we have regular curves. We are going to discuss periodicity. So let us differentiate the different terminologies for the periodicity. First, we have nocturnal, meaning these worms are only active at night. Diurnal, meaning these worms are active at day while inactive at night. And we also have non-periodic. Non-periodic means that they can be active at day and at night. Thank you so much for listening to our topic. Thank you, and that will be all for the physical characteristics of our blood and tissue nematodes.
The vector for Loa Loa filariasis are flies from two species of the genus Chrysops. During a blood meal, an infected fly introduces third-stage filarial larvae onto the skin of the human host, where they penetrate into the bite wound. The larvae develop into adults that commonly reside in subcutaneous tissue. The female worms measures 40 to 70 mm in length and 0.5 mm in diameter, while the males measures 30 to 34 mm in length and 0.35 to 0.43 mm in diameter. Adults produce microfilariae measuring 250 to 300 micrometer by 6 to 8 micrometer, which are sheeted and have diurnal periodicity. Microfilariae have been recovered from spinal fluids, urine, and sputum. An infected black fly genus Simulum introduces third-stage filarial larvae onto the skin of the human host and penetrate into the bite wound. In subcutaneous tissue, the larvae develop into adult filariae which commonly reside in nodules and subcutaneous connective tissues. Adults can live in the nodules for approximately 15 years. Some nodules may contain numerous male and female worms. Females measures 33 to 50 cm in length and 270 to 400 micrometer in diameter, while males measures 19 to 42 micrometer by 130 to 210 micrometer. In subcutaneous nodules, the female worms are capable of producing microfilariae for approximately 9 years. The microfilariae measuring 220 to 360 micrometer by 5 to 9 micrometer are unsheeted and have a lifespan that may reach 2 years. They are occasionally found in peripheral blood, urine, and sputum, but are typically found in the skin and in the lymphatics of connective tissue. A black fly ingests the microfilariae during blood meal. After ingestion, the microfilariae migrate from the black fly midguts through the hemocoel of the thoracic muscles. The third stage infected larvae migrate to the black fly proboscis and can infect other humans when the fly takes a blood meal. Typical vector of Brugia malai filariasis are mosquito species from the genera Mansonia and Aedes. During a blood meal, an infected mosquito introduces third-stage filarial larvae onto the skin of the human host and penetrate into the bite wound. They develop into adults that commonly reside in the lymphatics. The adult worms resemble those of Wuchereria bancrofti, but are smaller. Female worms measures 43 to 55 micrometer in length and 130 to 170 micrometer in width, and males measures 13 to 23 millimeter in length by 70 to 80 micrometer in width. Adults produces microfilariae.
measuring 177 to 230 micrometer in length and 5 to 7 micrometer in width, which are sheeted and have nocturnal periodicity. The microfilariae migrate into the lymph and enter the bloodstream, reaching the peripheral blood. During the day, they are found in the peripheral blood, but during the non-circulation phase, they are found in the lungs. The fly ingests microfilariae during a blood meal. After ingestion, the microfilariae lose their sheaths and migrate from the fly's midgut through the hemocoel of the thoracic muscles. There, the microfilariae develop into the first stage larvae and subsequently into third stage larvae. The third stage infected larvae migrate to the fly proboscis and can infect other humans when the fly takes blood meal.
And now, let's go to the diseases associated with these filarial nematodes. But first, I would like to emphasize their manifestations. Disease manifestations include lymph nodes, which is also called lymphadenitis, irregular fevers, and lymphedema. Lymphedema is the obstruction which causes enlargement in the organs. Repeated and chronic infections may result in elephantiasis. What causes these manifestations? Manifestations are due to lymphatic dysfunction resulting in the presence of living and dead worms, inflammation in immune reaction to worms and worm products. Let's go now to the first parasites. First is the Wucherea bancrofti. It causes elephantiasis in the upper limbs. Next is Rubigia malayi, which also causes swelling or elephantiasis but differs in Wucherea bancrofti because manifestations and symptoms are seen in the lower limbs. Next is the Onchocerca volvulus. Patient presents with cutaneous nodules, dermatitis, and eye lesions. And the last parasite is the Loa loa, which is also called the eye worm because it localizes in the conjunctivitis of the eye, which causes the disease calabar swelling. So that's it.
So for the filariasis, we have two kinds of drugs. We have the ethylcarbamazine and ivermectin. For the DAC is for the 6 weeks, 6 milligrams per kilogram, and has the important disadvantage of producing significant side effects. For the ivermectin, it is almost equally effective as DAC for 12 days in rapid clearance of microfilariemia.